Okay, so let's look at proving that root 2 is irrational. Okay, this is example 1. So say you assume it's rational. That's the first step. Okay, so what does rational mean? It means it can be expressed as a fraction in simplest form. So, okay, so root 2 is equal to a over b, where a and b are co-prime. So that means 1 is only shared factor. So you can't simplify this. Okay, can't simplify. That's the main thing. Okay, so then we follow a series of logical steps. So root 2 times b is equal to a. If we square both sides, we get 2b squared is equal to a squared. Well, we know that 2b squared is even, right? So that implies that, because it's 2 times something, that implies a squared is even. Well, a squared is a times a. So if a times a is even, that implies that a is even. So let a equal to n for some n bigger than or equal to 1, I guess, right? Okay, so we substitute that back in here. 2b squared is equal to a is equal to 2n, so 2n squared. So 2b squared is equal to, if we expand that, 4n squared, divide both sides by 2, and we get b squared is equal to 2n squared. Now, 2n squared is even, and that's equal to b squared, so that implies b squared is even. So this is the same logic we used just up there, which implies that b is even. So let b equal to 2m for some m bigger than or equal to 1. Now hang on a second. Our assumption, what was our assumption? That root 2 was rational. So we know that root 2 is equal to a over b, but a, remember, is 2m, we've shown, because it's even. And b is equal to 2m. And that, we can see, this has a common factor of 2. So, can cancel. So AB, not coprime. And that is our contradiction. That's how you write a contradiction. The only thing we've assumed is that root 2 is rational. So that, we've come up with a contradiction. So therefore, by contradiction, root 2 is irrational. There we go, done.